Good morning, ma'am. Myself, B. Balaji. I am from AAA department from A section. Today's my topic is state and explain the following theorems with step-by-step procedure. And coming to first one, Thevenin's theorem and Norton's theorem. And second one, superposition theorem. Third one, maximum power transform theorem. Fourth one, reciprocity theorem. Fifth one, compensation theorem. First theorem, Thevenin's theorem. The statement of an Thevenin's theorem is Thevenin's theorem states that any two-terminal linear network having a number of voltages and current sources and resistance can be replaced by a simple equivalent circuit consisting of a single voltage source in a with a resistor. Theorem, a two-terminal circuit can be replaced with an equivalent circuit of an ideal voltage source V voltage Thevenin in series with a resistor R Thevenin, and V Thevenin is equal to the open circuit voltage at the terminals, and R Thevenin is the equivalent or input resistance when the independent sources in the linear circuit are turned off. And this is a circuit diagram of an Thevenin's theorem. When linearly two terminal circuits is going towards passing towards a load. Next one, coming to Norton's theorem. The statement of a Norton's theorem is any linear bilateral complicated circuits with multiple energy sources and resistance can be replaced by a constant current source in parallel with a resistor connected across the load. And this was introduced by Edward Lowry Norton, and this is a Norton's equivalent circuit when a linear complex network is connected to an RL. And in the diagram there are IN and RN where we can see, and that IN is called as the short circuit current through the terminals, and RN is called input or equivalent resistance at the terminals when the independent source are turned off. The basic steps to solve Norton's theorem is first step is identify the load resistance RL and short the load terminal of the circuit. And second step is by utilizing any network simplification technique, determine the current flowing through the shorted branch. This current will be the Norton's current IN. And coming to third step, now remove RL from the given circuit and replace all the active sources with their equivalent internal resistance. And coming to fourth step, further equate the equivalent resistance across the open end of the circuit. This resistance will be the Norton's equivalent resistance Rn. And coming to last fifth step, now draw Norton's equivalent circuit comprising of IN in parallel combination with Rn across the load resistance RL. Then find the current through the load resistance RL by using this. Coming to superposition theorem, the statement of a superposition theorem is superposition theorem states that in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of response caused by individual source acting alone while other are not operative. And this is a circuit diagram of a superposition theorem, and the superposition theorem containing two voltages and three resistors. And coming to maximum power transfer theorem statement, the maximum power transfer theorem states that in a linear bilateral DC network, maximum power is delivered to the load when the load resistance is equal to the internal resistance of a source. If it is in an independent voltage source, then its series resistance, or if it is in independent current source, then its parallel resistance must equal to the load resistance RL to deliver maximum power to the load. And this is a circuit diagram of an maximum power transfer theorem. And the condition for maximum power transfer is RL must be equal to RI. And the formula of a maximum power transfer is power maximum transfer is equals to voltage Thevenin by Ri plus RL whole square into RL. That gives ratio that equals to voltage Thevenin square by 4 RL. And coming to the theory of an reciprocity theorem is the reciprocity theorem states that the current at one point in a circuit due to a voltage at a n second point is the same as the same current at the second point due to the same voltage at the first. And the limitations of this theorem is that is if it is applicable only to single source networks and not in the multi source networks. The network where reciprocity theorem is applied should be linear and consist of resistors, inductors, capacitors and coupled circuits, and the circuit should not have any time varying elements. And the theorem of an reciprocity theorem is in a linear bidirectional single source network the ratio of response to execution remains that the same even when the positions of response and execution are interchanged. Reciprocity theorem is applicable when the ratio of response to execution is either ohms or mhos ohms. And coming to second point, only one independent source is present in the circuit and no source is present in the circuit. And this is a circuit diagram of an reciprocity theorem. The statement of a compensation theorem is compensation theorem states any element in a linear bilateral network may be replaced by a voltage source of magnitude equal to the current passing through the element multiplied by the value of elements provided the current and voltage in other part of the circuit remains unrelated. And coming to the compensation theorem, in a linear bilateral network with independent sources, if an impedance Z with current I through it is changed to Z plus delta Z, then the incremental change in the current due to this will be same as the current produced by a voltage source I delta Z when connected in series with the new impedance Z plus delta Z in the new network with all the independent source being turned off. And these are the circuit diagrams of a compensation theorem. And thank you very much, ma'am.